So we have seen in the previous class that the definitions of what is computer vision, what is OpenCV, and how can we implement a computer vision concept using OpenCV. We just started with the basic operations we can do with the images, right? So what is computer vision? Computer vision is nothing but it's a field of artificial intelligence in which the computer going to learn or understand the real world with the use of images and the videos. Okay, so how can that computer going to learn these things? How can it understand the real world? It's all depend on the images we provide to the computer. So that computer should be trained before it is able to identify and recognize a particular object. It should be given with the lots of data set, so that it will able to identify and recognize that this is a particular object. Fine. So the study of these things will be studied in computer vision field. Okay, so the computer vision can be implemented in Python using a library OpenCV. Okay, so how can we get that library? So as this library is not a built-in library, you need to install it from the external source, and that for that purpose you need to use the different commands. Okay, so any one command is enough. Okay, so this is the standard command which is used to install the OpenCV from the Anaconda distribution. Okay, so apart from this there are two more commands, which is pip install OpenCV -python or pip3 install OpenCV -python. Okay, so any of these commands you can use. Okay, so that will be installed by opening an Anaconda prompt and typing this command in the Anaconda prompt, and keeping the internet connection to your system. You need to execute this command. Okay, so once you installed with this command, check it for the successful installation. So how can you check it? ಹೇಗೆ ಚೆಕ್ ಮಾಡ್ತೀರಾ? ಇನ್ಸ್ಟಾಲ್ ಕರೆಕ್ಟಾಗಿ ಆಗಿದೆಯಾ ಇಲ್ಲ ಅಂತ ಹೇಗೆ ಚೆಕ್ ಮಾಡ್ತೀರಾ? Tanmay, tell me, how can you check?
Print imported libraries imported. We'll try that.
Okay, so if you just import CV2, execute the statement import CV2. If that doesn't gives any error, so then it means that it is successfully installed. If it gives the error like no model named CV2 is found, then it means that it is not properly installed. Fine.
Yes, ma'am.
So next, once it is installed, after checking for the successful installation, we'll start with the basic operations we can do with the images. So what are the basic operations we can do with the images are these. So we can read the image and displaying it and saving an image are the basic operations we can do with the images. So how can you read the image? So reading is nothing but the loading an image into your program so that you can process it, so that you can use it to build an application, okay, which is based on the images concept only. Okay, so read is a function which is used to load an image into your program, so and that will be executed, that will be done by using this syntax. First we need to create an image object. In that image object we need to store the image which we want to be loaded to our program. So that will be done by like cv2.imread within parenthesis we need to give the file name, image name ಏನಿದೆ ಅದನ್ನ ಕೊಡಬೇಕು with the extension. You need to give it with the extension also, file name dot extension. And if you want to read it as it is, then you can set a flag bit here, and if you want to read it in a grayscale mode, so then reset this. Okay, if we give it as a 0, then this will be loaded as a grayscale image. Even though it is a colored image, it will be loaded as a grayscale image. If it is set, that means if the flag bit value is 1, then the image will be loaded as it is. Okay, so if you want to display an image, then use the function IamShow, cv2.IamShow, and the two parameters you need to specify. One is the window name, another one is the image object which you want to display it in that window. Okay, so next, along with this, you need to specify 2 more statements for the for the successful display of an image. If you didn't give these 2 statements, you will get an error. Okay, once you use the cv2.imShow function, so then you have to use these 2, wait key and the destroy all windows mandatorily. Okay, so wait key function, what does it do? Wait key function, what does it do? It will hold.
It will wait for the input.
Yeah, tell me. It will
wait for an input and close the window.
So not just input, it is used to hold a window which you are displaying an image. Okay, so the window which is displaying an image should be waited for some time, right? So to display it, we want to see it, right? So for that purpose it has to wait for some time. So that time can be specified here. If you want that window to be displayed for some amount of time, then you have to specify that time duration here as a parameter for this method. If it is specified as 0, then it will wait for the user to enter some key so that it will get closed. Okay, it will wait for infinite amount of time until and unless user press any key, it will wait before closing. Okay, if you specify some time, like if you want to display that window for 3 seconds of time, give it like 3000. So then the window will be displayed for 3 seconds and it will be closed. Okay, so if you give it like 5, it will wait for 5 seconds. Fine, so this is how it will work. So destroy all windows is used to destroy all the windows which are previously created. Okay, if you want to destroy a specific window, then you can also specify it just by using a method destroy window. Here you need to specify the window name. Okay, so this will also works. Okay, if you want to, like if you have created 2-3 windows, but you want to you want to destroy only single window which is lastly created, but the previous 2 windows are needed for a future process, so then you can use this method. In such cases you can use this method. Okay, so that's how we can deal with the basic operation with the images. Okay, reading and displaying, and writing an image or saving an image can be done by using a state method IamWrite. So cv2.IamWrite, here we need to pass 2 parameters. One is destination image name, and second one is the image object which we want to save as a image, another image. Okay, here for example, if it is a colored image and I want to read it as a grayscale image, and I want to save that grayscale image. Okay, cv2.IamWrite gray image.jpg. So image object will be image. So ಇಲ್ಲಿ ಈ ಇಮೇಜ್ ಆಬ್ಜೆಕ್ಟಲ್ಲಿ ನನಗೆ ಏನು ವ್ಯಾಲ್ಯೂ ಸ್ಟೋರ್ ಆಗಿದೆ, ಯಾವ ಥರ ಇಮೇಜ್ ಸ್ಟೋರ್ ಆಗಿದೆ ಅದನ್ನು ನಾನು ಸೇವ್ ಮಾಡ್ತೀನಿ. Okay, if I execute this, it will be available with this after 5 seconds it will be closed. So it shall check it for the image. So it is stored in the location. Up here, programming languages, EML, OpenCV. Here it is, gray image. Okay, so we just change it. I have flower. Okay, I have dog. Okay, so is it a colored image? Yes, right? So I shall read it in a grayscale mode and I shall save it. Dog. Okay.
ನೋಡೋಣ ಬಾ ಇಲ್ಲ ಹೇಳಿದ್ದೆ.
So and then let's check it for the name. If I in this gray image, what should be stored? Image ಅನ್ನೇಕ ನಾನು ಗ್ರೇ ಸ್ಕೇಲ್ ಅಲ್ಲಿ ರೀಡ್ ಮಾಡಿದ್ದೀನಿ and I have saved the same image as a by the name gray_image.jpg. Previously it was stored with the grayscale flower image, but now it has to be saved with the grayscale dog image. Okay, so let's check it out for that. See here, grayscale dog image is stored, right? So this is how we can perform different basic operations with the images. Okay, apart from this, so there are some more operations which are listed here. So please make a note of this thing when we shall implement all these things. So OpenCV basic operations or images are these. So first we can access the pixel values and modify them. We can access the image properties. We can setting a region of image or region of interest, and splitting and merging the channels, different channels or the layers or pages in the images. And we can change the image color from one color space to another color space. We are going to convert it. Okay, so please make a note of these things. Once you finish, please let me know.
Done.
Fine. So so this is how we can read an image when it is present in the local current directory, right? Local system, that is current directory. When it is present in the other directory, what you need to do, like other than the current working directly, if I am working in a C drive and it is present in the D drive, how can I read that image?
Copy path.
Copy the path of the image, I need to paste it here, and we need to give the entire path of the image which we want to read, which we want to work with. Fine. Fine, that's how we can read images in the which is present in the current directory and which is present in the other directory also. Fine. So what are the different extensions for these kind of images? Possible extensions are here. So we can read images with .bmp like bitmap files, DIB, JPEG files, portable network graphics files, and images with .ppm, .pgm, .ppm, .tif, .tiff. So all these extensions are allowed and valid to read By using a method, I am read. Okay, so just note down these methods. So these extensions, the image files with these extensions are valid to read in amread function. So once you finish, please let me know. Just note down the extension. What are the possible extensions for these kind of image files you have, and what are all allowed in the OpenCV library. Done?
Again.
Fine. So let us move on to the next operations we can do with the images. So how can we access the pixel values? You can just by printing the image. Okay, so whatever might be the image format, so whatever you have read using amread function, that image will be converted as a numpy array in Python. Okay, so if you are using the OpenCV library and you are reading an image using an image object, that image object will be store the image in the form of numpy array. ನೀವು ಇಮೇಜ್ ಯಾವುದನ್ನೇ ರೀಡ್ ಮಾಡಿದ್ರು ಅದು numpy array ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗಿ ಸ್ಟೋರ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ದ್ಯಾಟ್ಸ್ ವೈ ಒನ್ಸ್ ಯು ಪ್ರಿಂಟೆಡ್ ದಟ್ ಇಮೇಜ್ ಆಬ್ಜೆಕ್ಟ್ you'll able to get the values, array values there instead of just a image. ಇಮೇಜನ್ನು ರೀಡ್ ಮಾಡಿದ್ರೆ ಇದೇನು ವ್ಯಾಲ್ಯೂಸ್ ಬರ್ತಿದೆ ಅಲ್ಲ ಅಂತ ನಿಮ್ಗೆ ಅಂದ್ಕೊಂಡಿರ್ಬೋದು. ಸೊ ದ್ಯಾಟ್ಸ್ ವೈ ಯು ಆರ್ ಗೆಟಿಂಗ್ ದ array there. So the image will be converted to a numpy array, and that's how we can access the pixel values. We can get to know that what is the pixel value in the image. Okay, if you, from that image object we can get to know that what are the pixel values. Okay, next operation is accessing image properties. So what are the image properties? The dimension, how many number of rows, how many number of columns, how many number of pages are present for an image can be accessed by using a shape attribute. Okay, so to access the pixel values, just use the image object. Okay, so this is why you're going to get the arrays. Okay, every image will be converted to a numpy array, and then it will be processed. Okay, so that's the first operation. Second operation is accessing the image properties. Accessing image properties will be done by using a shape attribute. Okay, so this many, if I use the shape attribute with the image, then it will returns us the height, width and depth of the image. If it is of grayscale or the black and white image, you'll get only number of rows and number of columns as a return value, like height and width only. And if it is of colored image, then you'll also get the number of layers of colors with that image. Okay, so here it is read as a grayscale image, so that's why you'll get the error like that, values like that. Okay, fine. If now it is read as a colored image, so you'll able to get 3D matrix here, 3-dimensional matrix. Okay, so then if I get the shape of it, I'm able to get 3 layers also. For the colored images only, you'll get this number, and for the grayscale or the black and white images, you'll able to get only number of rows and number of columns as a return value from the shape attribute. Okay, so this is how we can able to get the properties of the image. Okay, so next is setting region of image. That means if we want to concentrate on a specific region, specific area in the image, then how can I get that? So that is the next operation. Okay, if I display an image, so cv2.imshow, so that will create a new window, and within that it will going to display an image. Okay, so we can also display it in a different way also, like by using a matplotlib we can also display an image. Okay, so that will be done by import matplotlib.pyplot as plt.imshow. So this will also display the image. Okay, so there are one way of reading an image by using cv2.imread, and there are 2 ways of displaying cv2.imshow, plot.imshow. Okay, so just turn off the axis. So you're not able to get the axis values. Fine. Okay, so you might have seen here, so 194 represents the rows. Rows means the height, so you'll able to get the values from 0 to approximately 200, right? 194 approximately 200 values namge height ide, and 259 is the width, so width will from 0 to 259. Okay, so image in size ಎಷ್ಟಿದೆ ಅಷ್ಟೇ ದೊಡ್ಡ image display ಆಗುತ್ತೆ. Okay, so along with the axis if you use the plot. Okay, next is the setting up the region of image. That means if you want this face region only of this dog, if you want to extract that and if you want to process it. Okay, so in such cases what should I need to do? I can use the slicing operation to extract, to concentrate on the region of image, region of interest in an image. Okay, so that will be done by using the row and column pixel values. Okay, row values and the column values. Okay, so if this image is of shape 194, 259, so I want just face to be extracted, or I'll just part of the image I'm going to extract. So okay, so I'll start from here and I'll just split up the first half. Okay, so if this image is divided into 2 parts, and I'll just access the first half. Okay, so it will assume that, so start from 0th row from 0th row till the end, from 0th column till the mid portion. Mid portion will be like 260, 130. It's 130. Okay. So if I plot this, okay, so first half will be extracted. If I want to be the second half, what are the values should I need to pass here? So this is the all the rows, only 50% of the columns are extracted here. I want the next 50% to be displayed here. So then what are all the values I need to pass here? I need to consider. It's from
130 is to 250.
1. Okay, 120 is to 250, something like that. It's not like I want all the rows and all the columns. It's from 130 is to, it's from 259 alva. Okay, so next stuff will be gets printed here. So we'll display it. Okay, first half and the second half, not from 130. So we'll start from 131. Fine. So this is how we can split up the regions. If this image is divided into 4 parts, or I just want this face to be extracted, then what are all the possible values I should pass here? I should consider here. I want face of this dog to be extracted. Then what
Rows
are
and
the
columns both we should divide.
both
Rows and columns we must
rows and
cut
columns we should give. So what's the range of values we should consider for both rows and columns? Possible. Just say approximately.
30, 35 in rows.
Okay. Just consider from 30 to about 150th row, and from columns from 50th to 220, shall I consider 50th to 230. So if I get that, just only face will be extracted here. Okay, so this is how we can set the region of image. We can concentrate and extract whatever region of interest will be present for an image. Fine. So this is how we can extract a region of interest from an image. Okay. Take a note of this thing. So this is how we can read an image, and this is how we can plot an image. So note down how to plot it. Then try to split up the image. done this also. Just I1. Fine. So next we shall see how to split up the channels. Just now we have seen how to set up the region of interest. That means how to slice the rows and columns of pixels in an image. Then what about the channel? So we can also able to split the channels, individual channels also we can extract and display and process. Okay, so for that purpose we can use the same method. Okay, so can anybody guess how can we extract a channel? So I'm going to import the library. Next I'm going to import the image, read an image, cv2 dot using a amread method, use flower.jpg. So because this file is present in my current directory. Okay, so here it is, flower.jpg, here it is in my current directory. So that's why I'm just giving it the name directly. Okay, so next if I want to display it, plot dot show image, plot dot show. Okay, this is the image. Next if I want to split up the channels, so what I'll get, this is a colored image, right? So if I get the shape of it, we'll able to get three values. One is height, width and number of channels, number of layers or number of pages. Okay, so if I want to split up the channels, I can consider this value and we can separate it. Okay, so that will be accomplished by using index slicing. Image of all the rows, all the columns. First channel will be for blue channel, blue layer it is, because whatever the images you have read using OpenCV library in Python, then it will be loaded as in a BGR format, not in a RGB format. Whatever the objects, whatever the images we will see, that will be in the form of RGB format, but OpenCV reads it in a reverse manner. Okay, BGR format. So for that purpose, the first layer is blue. It's a blue layer. Second is the green layer. For this layer, what is the value? Can somebody tell me? Kirti? Nandish, tell me what can be
One.
Yes, tell me.
IMG bracket colon comma 1.
1. So this is how the second channel will be present, extracted. For the red channel, it is image comma
2.
2. Okay, so this is how channels can be extracted. So let us try to plot this dot. I'm just display it using a cv2 only. cv2 dot show blue channel, it is for blue, for green, it is for red, it's also for green, and it's for red. Okay, and cv2 dot wait key, we'll wait for infinite amount of time. So cv2 dot destroy all windows. Okay, so if I execute this, we're able to get this is the red channel, this is the green channel, so this is the blue channel, and here is the original image. Okay, so have you observed here, in each channel you are able to see only grayscale images only. So why this happens?
One dimensional values.
Yes, as it is a one-dimensional matrix, single layer of matrix will be present for each channel. It will able to display only two possible values, like highest value, lowest value, or in between the shades. But when you merge them back, when you combine them back, you'll able to get the colors. Okay, so let us try that. We'll merge them back and we'll see. Okay, so that merging can be done by using a method called cv2.merge, and you need to pass blue, green, red. Okay, so if you display just don't want this to happen. Okay, colored image, this is colored one. See here, when you merge them back, you'll able to get the final again colored image. Okay, so it is in the BGR format. I want it to be in a RGB format, so then what should I need to do? Here itself, come on, is your
first
red,
red,
first red, then green,
green and
blue. So if I run this, I'll able to get the original image. Okay, so as it is in the CV2, it will be displayed like that itself. Okay, if you again merge the same channels again, some colorings, red shades will be more. If you merge the blue channel, so blue and blue is more, able to read with the green, colorings will be different. Okay, we can say take out the same channel, so ಎಲ್ಲ ಕಲರ್ಸು ತಗೊಂಡ್ರೆ ಅದೇ ಥರ ಬರುತ್ತೆ. ಓಕೆ, ಒನ್ ಚಾನಲ್ನೇ ಸಪ್ರೇಟ್ ಮಲ್ಟಿಪಲ್ ಟೈಮ್ಸ್ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಮರ್ಜ್ ಮಾಡಿ ನೋಡ್ಬೋದು. ಓಕೆ, fine. So this is how you can split the channels and you can merge them back to get back the original colored image. Okay, fine. And then ಇಲ್ಲಿ ಟ್ರೈ ಮಾಡಿದ್ವಲ್ವ, ಮರ್ಜ್ ಮಾಡಿದಾಗ ಫಸ್ಟ್ ರೆಡ್, ಫಸ್ಟ್ ಆಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಗ್ರೀನ್, ನೆಕ್ಸ್ಟ್ ಬ್ಲೂ ತೊಗೊಂಡ್ರು ಇಮೇಜ್ ಆ ಥರನೇ ಬಂತು ಅಲ್ವಾ. ಸೊ ವಿಲ್ ಜಸ್ಟ್ ಮೈನರ್ ಡಿಫ್ರೆನ್ಸ್ ವಿಲ್ ಬಿ ಅಪಿಯರ್ಡ್. ಓಕೆ, ಸೊ ಬ್ಲೂ ಆ್ಯಂಡ್ ದೆನ್ ರೆಡ್. ಓಕೆ, ಕಲರ್ಡ್ BGR, colored RGB. Okay, just display all of them together, so then we can able to make out the difference. Colored RGB, colored BGR. Okay, are you people able to make out the difference? Okay, if this is of this, I shall read the another image so that you can able to make out the difference. Okay, this is the RGB original image. So this is the colored BGR. ಡಿಫ್ರೆನ್ಸ್ ಕಾಣಿಸ್ತಿದೆ ಅಲ್ವಾ? ಸೊ BGR ಮಾಡಿದಾಗ ಆ ಥರ ಆಗುತ್ತೆ. ರೆಡ್ ಚಾನಲ್, ಗ್ರೀನ್ ಆ್ಯಂಡ್ ದೆನ್ ಬ್ಲೂ. ಸೊ ಇದು ನೋಡಿ, ಬ್ಲೂ ಎಲ್ಲಿದೆ ಅಲ್ಲಿ ಮಾತ್ರ ಹೈಲೈಟ್ ಆಗಿದೆ, ಬಿಕಾಸ್ ಬ್ಲೂ ಚಾನಲಲ್ಲಿ ಬ್ಲೂ ಪಿಕ್ಸೆಲ್ಸ್ ಏನಿದೆ ದ್ಯಾಟ್ ವಿಲ್ ಹ್ಯಾವ್ ದ ಹೈಯೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂ ಆ್ಯಂಡ್ ರೆಸ್ಟ್ ಆಲ್ ವ್ಯಾಲ್ಯೂಸ್ ವಿಲ್ ಬಿ ಲೋವರ್, ರೈಟ್? ಗ್ರೀನ್ ಚಾನಲಲ್ಲಿ ಗ್ರೀನ್ ಕಲರ್ಸ್ ಇರೋ ಏರಿಯಾಸ್ ಮಾತ್ರ ಪಿಕ್ಸೆಲ್ ವ್ಯಾಲ್ಯೂಸ್ ಹೈ ಇರುತ್ತೆ, ಉಳಿದಿದ್ದು ವ್ಯಾಲ್ಯೂಸ್ ಉಳಿದಿದ್ದು ಎರಡು ಲೇಯರ್ ವ್ಯಾಲ್ಯೂಸು 0 ಇರುತ್ತೆ. ಇನ್ ದಿಸ್ ಆಲ್ಸೋ ಇನ್ ದ ರೆಡ್ ಏರಿಯಾ ವಿಲ್ ಹ್ಯಾವ್ ದ highest value and in the rest all the parts will have the values layers values will be 0. Okay, so ನೋಡಿರಲ್ಲ, ನಾನು ಫಸ್ಟ್ ಇದು ಯಾವುದರಿಂದ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿದ್ವಿ? ಒರಿಜಿನಲ್ ಇಮೇಜ್ನ ರೀಡ್ ಈ CV2 ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಏನು ರೀಡ್ ಮಾಡಿದ್ವಲ್ಲ ಇಮೇಜ್, ಸೊ ಅದನ್ನು ಅದರಿಂದ ಸ್ಪ್ಲಿಟ್ ಮಾಡಿದಾಗ ಬಂದಿರೋ ವ್ಯಾಲ್ಯೂಸ್ ಇದು. ಸೊ ಇಫ್ ಇಟ್ ಈಸ್ ರೆಡ್ ಆಸ್ ಅ RGB ಫಾರ್ಮ್ಯಾಟ್, ದೆನ್ ಇಲ್ ಏಬಲ್ ಟು ಗೆಟ್ if it is of blue channel, then this part should be higher, this part should be brighter one, right? But this is brighter, that means, so this is according to this format. Okay, the image will be read as in the BGR format in CV2 and it will be converted to RGB format just by merging the layers in the reverse order. Okay, so then you'll able to get the difference of it. Fine. So that's how we can able to split the channels and match them back. Okay, and what are the rest operations we are left with? Changing the image color. So changing the image color can be done in this way also, and we can also use the built-in methods to change the color space of an image. Okay, so this is one way of changing the image color. So another way is using a built-in method called CVT color. Okay, so CVT color is the method which is used to change the color space of an image. It will change the image from one color space to another. If it is in the BGR format, we can convert it to RGB format. If it is in a RGB format, we can convert it to a BGR format, or we can convert BGR to a gray and RGB to grayscale. Okay, so these are the 4 different options we can do. We can change the color space, to change the color space of an image. Okay, so let us try this. How can we do this? Just first we need to read the image. Original equals cv2.amread rgb.jpg. If you want to change the color space to gray, original to gray. ಸೊ ಒರಿಜಿನಲ್ ಯಾವ ಫಾರ್ಮೆಟಲ್ಲಿ ಇರುತ್ತೆ ನಾವು ರೀಡ್ ಮಾಡಿದಾಗ it is in the form of BGR format, right? So we want to convert it to grayscale. So for that purpose we can use the built-in method called CVT color. So for this method we need to pass 2 parameters mandatorily. First one is the image object, source image object, and another one is the code which represent from which space to which color space the image has to be converted. Okay, so then image, it's a original, we want to convert this original image to gray. So that code will be cv2 dot color underscore bgr to gray. Okay, if I display that, we'll just plot it. Okay, so now we shall plot it. Just display it when it's using it's a original to gray and it is original. Okay, so we have converted this original to gray. Okay, this will be in the form of BGR. It will be converted to a grayscale mode. Okay, to reduce the complexity, to increase the efficiency, to reduce the calculations, we are going to most of the algorithms are going to use this conversion from BGR or from RGB to grayscale conversion is going to use in most of the algorithms. Okay, so this will reduce the complexities which can in the image processing. Okay, so this is for conversion of image from BGR space to grayscale. Okay, so now we shall convert it to RGB format. Original to RGB. Okay, for that purpose just change this. Okay, need to display this. Okay, this is RGB and this is BGR. Okay, in this way also we can change the image colors. Okay, the pixels in the image can be changed its color by using different methods and by using the slicing operations also. Fine, is this clear? Okay, fine. So take down this. You can use these two methods to change the color space of an image. Image color conversion ಈ ಎರಡು ವೇನಲ್ಲಿ ನಾವು ಮಾಡ್ಬೋದು. Okay, so now on this Once you finish, please let me know. Observe here, for the CVT color method, C is in a uppercase. CVT color, for color, C in a uppercase. Right? So these are the two ways of spreading up the channels and individually process them. Okay. So now let's try to plot a histogram for the individual channel. Histogram can be plotted using a matplotlib library, right? So plot dot using a method hist. So what's the purpose of drawing histogram? So histogram is a very important tool in the image processing because it will give the distribution of the values, distribution of the elements in the entire image. Okay, entire like how the pixel values are distributed in the entire image, that will be easily analyzed in by using the histogram of an image. Okay, the image histogram will give you the graphical representation of the distribution of pixel intensities in the image, how the pixels are distributed, how the pixel intensities are distributed. So that information can be easily analyzed from the histogram, image histogram. Okay, so here x axis will represent indicates the range of values the variable can take, and y value will represent the frequency of a pixels, number of pixels, how many will be present for a particular valued particular intensity. Okay, in the blue channel the pixels with between 0 to about approximately 25, so it will be about 400. Okay, so most of the pixels are in the range of 0 to 10 or 0 to 20 will be more, 0 to 25 it will be more, approximately 400 pixels will be present which have the pixel intensity within 25, and about 200, 250 to 230 pixels will be present which have the values highest value, like about 250 intensity. Okay, so this is how we can get to know that how many pixels will be present with what value of intensity in an image. Okay, if I do it for the same for red channel, so the values will be different. Once we plot the histogram of a image, we'll able to get the distribution of the pixel intensity in an image. So this will gives you the information about the distribution of the pixels. Fine, wait for a while, it will give you the all the histogram plots for the different channels. Okay, this is for, give a title for this. This is for blue layer, this is for green layer, and this is for red layer. So this histogram will give you the an intuition regarding the some properties of the images, such as like contrast, brightness of the image, so how much contrast it is, so what's the pixel intensity, how many pixels with the lower intensity, how many pixels will be present for a higher intensity, and can be classified into different groups. So that can be analyzed by using the histogram. Okay, so this is how, so this is for blue layer. So in the blue channel the pixels will be distributed like this. The pixels with a very low intensity are this much, and with the high intensity are this much. This is in the green layer and this is in the red layer. Okay, so we shall do it for a different image.
Ma'am, actually I'm getting an error, ma'am.
What's the error?
Ma'am, I paste it in the comment box.
Okay, just a second. I didn't get it.
No, ma'am, I paste it now.
Okay. Assertion failed, which means that the image is not loaded properly. Okay, so if the image is not loaded properly, then you'll get error like this. So try to check out for whether that image is present in the current directory or not, whether you are giving the proper path for that file, for that image, the amread function. Just check it out for that. Then
Ma'am, above codes all were running, ma'am. This one is not running. That
what?
original two. That CVT code.
Yeah.
Before that, all the codes were running, ma'am. That CVT
So
code is
can
not.
you paste that, send that code
Okay, ma'am.
what you are using? Is this JPEG? Is this image is available in the current directory of in your system?
Yes, ma'am.
It's JPG or JPG. Try to find out the extension also.
JPEG only, ma'am.
JPEG only.
Yes, ma'am.
Check it out again. CVT color BGR to gray original to RGB. See, it's the right code, but your okay, original to RGB CVT color. Okay. Just this one is like I think the image name is not proper. Check out the file extension also. It's like rgb.jpg or jpeg or
JPEG only, ma'am.
jpeg only. Are you sure of it?
Yes.
Like path.
Yes,
What
ma'am.
about the path?
Path also correct only, ma'am. I have copied. I have opened the properties and checked it.
Okay, here path is here. Just the file name is present. Is it present in the current directory?
Ma'am, it's on the desktop. Like I have copied the path and pasted it there.
Where is the path here? Just a file name is present here.
No, ma'am. Above operation, I have run this, ma'am. I should paste
No,
that code.
if you are reading here, then you have to give the path for this file. If you are just specifying the name of the file with the extension here, it means that this file is present in the current directory. It will check for that condition. If that file is not present in your current directory, it will give us an error. Okay. So previously you might given the path, but here also once you are reading this reading that image, then you have to give the exact location of it. Okay, ಮುಂಚೆ ಒಂದ್ಸಲ read ಮಾಡಿದ್ರೆ
Ma'am, this path, ma'am. This
Yeah.
path I should paste it there, ma'am.
What this path? Okay, you need to give this path here also, and give this forward slashes only, not in the backward slash. Once you copied it, it will be in the backward slash. Try to convert it so it's in the correct format. Give this path before this file name. Okay, then execute it.
Instead of that RGB, I should give that path, ma'am.
Instead of that just append the path before this name of the file. Okay, so
Okay.
it will check for the, like, once you given the location, once you given the file name here, it will check for the location also. Okay, just given, if you given the file name, it will check for the current directory, whether that directory contains this file or not. If that file is present in the current working directory which your notebook is open, then only it will read the image. Otherwise it will give us an assertion error. If it is present in other directory and you are using it here, then you should give it along with the path also. Okay, so c/user/tanam and OneDrive/desktop/rgb.jpeg. Okay, the entire path you should give and then execute it.
Okay.
Fine. So that's how you can read a image. So this is how you can draw a histogram for a different layers to know the distribution of pixel intensity in an image. Okay. Fine. So next, if you want to read story, okay, try to note down this code, execute the code, same. Plot histogram for all the 3 layers. Fine. So next we shall discuss about the one more next concept, which is a thresholding. Okay, so how can you perform thresholding in OpenCV in the field of image processing? So can you tell me what is thresholding? Thresholding. So is the next concept. So thresholding is nothing but it's a technique wherein which you are going to assign the pixel value in relation to the threshold value which is provided by the user. Okay, so there is a changing of the pixel values. Right, the first basic operation is changing the pixel, getting the pixel values and changing the pixel values, right? So that changing we can do here. Okay, so thresholding is nothing but it's a technique in the field of OpenCV, the computer vision, wherein which you are going to assign the pixel values. We are going to change the pixel values with respect to the threshold value which you have provided. Okay, so assign the pixel value with respect to threshold. Okay, with respect to the threshold value, you are going to change the pixel value in the which is present in an image. It can be of colored image or it can be of a grayscale image, but most of the time this kind of operation will be performed on the grayscale image only. If it is of colored image, it will be converted to a grayscale image, and then this operation will be performed on that image. Okay, so in thresholding, every pixel value is compared with the threshold value. If the pixel value is smaller than the threshold value, then one value will be assigned to the pixel. If otherwise, if it is set to the maximum value which is provided. Okay, so every pixel value which is compared with the threshold value which we have provided, like if we have the what is the maximum and the minimum value a pixel can have, it's from a minimum value a pixel can have is minimum brightness intensity value a pixel can have is, come on, tell me, it's 0, right? So 0 to 255, the pixel intensity can be vary from 0 to 255. If the pixel is with the intensity 0, it means that it is the darkest pixel. That means that the pixel is with the darkest intensity. And if it is with the 255 value or the value which is nearer to 255, that means it's the brightest pixel in the image. Okay, if you want to change any other pixel in the image, you can convert it, you can set a threshold value and you can convert the other pixel value with respect to this threshold value. Okay, if the pixel value is observed pixel value is less than the threshold value, then we can make it to 0, or if the observed pixel value is greater than the threshold value, we can make it to 255 or the value which is fixed by us. Okay, so this process will be called as thresholding. We'll say change the pixel value with respect to the threshold value. Okay, so these kind of things will be most often used in the medical field. Okay, so let us implement this. So one thing, if we didn't have the images, so for proper images for working with these kind of operations, we can find our images where some images will be uploaded to our GitHub page. We can just go to there, search for github.com/abhyantrix2 internship. Go to here, go to intern page, and here download this. Okay, here in this image folder we have lot many images. We have uploaded it, and you can use those for your study. Fine. Okay, this image is this folder is downloaded, so the folder will be downloaded as a zip file, so you need to extract it. Okay, so just extract it wherever you want to store. Extract to desktop. So just extract it to the desktop. It will be extracted. So in the desktop you can see that intern main. So there is all the files will be present in that image folder. Image folder, you have lot many images here, and you can use any of this to for your study. Okay, so here, right, so let me use this cameraman image in my example of thresholding. Okay, fine. So first read this image, import CV2 source equals CV2 dot amread cameraman dot png. So read it as a grayscale mode. Okay, check out for the successful loading. Source dot shape. So it is obtained. It is 513. Okay, you can check out for the extension here. So cameraman it is TIF. It is TIF. So it is executed. Okay, just a sec. My current folder is different here. My current folder is present. And copy it here. Just copy the path. Change these slashes. Images slash. Okay, so this is how you can read an image. Okay, so then thresholding. So what happens here? Now we just plot it using matplotlib library. Plot dot. Now I'll go to use it using subplot. Plot dot. I am sure what is subplot. You might have some familiar with these methods, right? So I'll plotting graphs. You might have used what does plot operation will do, histogram will do, subplot, right? So it is source plt dot show. Okay, so while plotting it, you should plot it by using a cmap equals gray. Okay, so now I just plot a histogram for this image. How can I do it? Plot dot stuff source. Okay, so you might have seen this here. Only few colors are present. One is black and the another one is gray and only some part will be of white. Okay, so this is the histogram for the image. And some part will be, fewer pixels will be of white color. Okay, so if I if I observe this image, most of the background colors will be in the grayscale, right? So only if the front object, that is a cameraman who is holding a camera, will be in the black shades, right? More of the black color will be present for here. Like if I observe this image, I'll get the pixel values. Most number of pixel values will be in the range of, which is nearer to 255, 127, right? So it is almost nearer to grayscales. Okay, so now we shall try to keep up the darker portion here and the light portion more to make it more lighter. Okay, so then what's the condition? If the pixel values which is greater than, like grayscale means I'll consider from 100. Okay, so it will be from exact middle portion will be 127, but the pixels which will be in the range of, which is nearer to 127, will also be appear in the gray shade itself. So I'll consider 100 as a value, threshold value. I'll set the threshold value to 100. I will convert the pixel values which are greater than this threshold value to more brighter in the sense the pixel values intensity should be high. The pixel intensity should be high in the sense we will make it as 255. Okay, so we shall make it. Okay, so in the image which I have read, within that, if the source pixels are greater than value 100, make it as 255. Okay, all the pixels in all the rows and all the columns, if the pixels have values intensity which is greater than 100, make it as 255. Okay, so and then if I try to plot it, after this operation, if I try to plot it, see here, the background will be clear, right? So just okay, so background is clear now, right? So the most of the pixels which will be in the gray shades, lighter intensity pixels, will be, make it as highest intensity pixels. Okay, so if I want to make it the darkest pixels to more darker, then just change the condition. Less than 100, make it as 0. So this will, okay, darker pixels will become more darker. You might have seen here. So this portion will not be clear here. So less than pixel values which is less than 100 will be more darker here. Okay. So this is how I can set the threshold and I can change the pixel value of an image. Fine. So apart from this, so there are also built-in methods which are available in this library, so that using those we can implement thresholding concept. So there are different thresholding techniques which are available in this library, so OpenCV library and the Python programming. So those are binary thresholding, binary invert thresholding, truncated thresholding, and 2-0 thresholding, 2-0 invert thresholding. Not that I will give you the notes for this. I'll send this file to you. Okay, so there are different built-in methods for implementing this thresholding concept. Okay, so basically there are 3 different types of thresholding Okay, so this is how the thresholding can happen. Okay, so the threshold value will be set first, then the pixel values will be compared with this threshold value and changed accordingly. Okay, so as we have specified this condition, like whatever the pixels which have the intensity which is less than 100, will make it as 0. That means darkest pixel, make it as a darkest pixel. Okay, so like the same way we can set the threshold value and implement thresholding concept. Okay. So the built-in, as I said, so there are different thresholding techniques in Python. So those are thresholding types. Kinds of thresholding are simple thresholding, adaptive thresholding, obtuse thresholding. So these are the different types of thresholding techniques which are available in Python. Okay, so we can have a built-in methods to implement these different types of thresholding techniques. Okay, so let us see how can these different types can be implemented and what's the difference between these types and how can we implement those. Okay, so first one is the simple thresholding. Okay, so simple thresholding is the first the basic type in thresholding. So the basic thresholding technique is simple thresholding, which is also called as binary thresholding. It's also called as binary thresholding. Okay, so because as all the pixels in the image will be compared with the threshold value and will be converted to the specified value, right? So for every pixel the same threshold value is applied, and if the pixel value is smaller than the threshold value, it is set to some value, and if the pixel value is greater than the threshold value, it is changed to some other value, right? So but in case of simple thresholding, the pixel values which is less than, which have the intensity which is smaller than the threshold value, it is set to 0. Otherwise it is set to maximum value. That means if I provide the threshold value as 100, if the pixel value is found to be with a less intensity than this threshold value, those will be converted to 0. If the pixel values which is found to be greater than this, then those will be converted to 255. That means finally you are able to get only 2 possible colors in the final image. So that's why it is called as binary thresholding. Okay, if pixel value is less than threshold value, then it is set to 0, and if pixel value is greater than threshold value, then it is set to 255, maximum value. Okay, so this is how simple thresholding can be implemented. Okay, so let us implement this. I'll show you the different kinds of thresholding. Okay, so here also different thresholding techniques will be present. Okay, so the different simple thresholding techniques are binary, binary invert, okay, it should be given in a caps. Okay, binary invert, truncate 20 invert. Okay, so these are the different thresholding techniques, different simple thresholding techniques. Okay. So it can be given as threshold binary, should be specified as different techniques, should be specified as cv2 dot threshold, cv2 dot threshold binary, threshold binary invert, threshold truncated, threshold 20, threshold 20 invert. These are the different thresholding techniques in simple thresholding. So these techniques can also be implemented with the adaptive thresholding and the outsource thresholding also. Okay, so these are the basic techniques, different techniques in thresholding, and these can be used with all the types of thresholding. Okay. So just note down these wordings. Here this maximum value is as per the user input, like this can be fixed by the user or the programmer. Okay, this is not there is no mandatory rule that it has to be 255. You can set it to 250, 200, but it has to be within 255 because the pixel can have the value up to 255 only. So this should be within 255, or it is, if it is 255, no issues. Okay, so let us implement this. First, import the library. Next, read the I1 equals cv2 dot imread, read the image. So now for now we're going to read some more image which is called coins. Okay, I'm going to use coins. Coins.png. So coins.png is my image. So let's just display it. Just use the subplot. I1. Okay, if it is read as 0 grayscale image, it will be plotted. So now we shall implement with the simple thresholding. Simple thresholding can be implemented using a method called threshold. Okay, so this will returns two values. One is the return value which specifies that this method is executed properly or not. Okay, so return value, and we need to store it in the value. We'll first implement binary threshold. Give it as binary. Okay, so cv2 dot threshold I1. First one is the image object. Next one is the threshold value we need to specify. Next is the maximum value. Finally, the technique. Okay, so observe here only black and white colors are appearing here. The pixel values which is less than 100 will be converted to a pixel intensity of 0 value, and if the pixel have the intensity which is greater than 100 will be changed to value 255. So threshold value and the maximum value should be given by the programmer itself. So if you set it to 200, you can set. No issues. Okay. This is the original image, this is the threshold binary. Okay, so let's do it for other methods also. Threshold binary invert, threshold truncate, threshold 20 invert. Okay, so I'll change the name, threshold invert, it's not binary, it's a truncate. It's 20 invert. Okay, so let's just plot it. Like on 5 6 3 2 rows 3 columns we should plot. 2 rows 3 columns. Two, three, one, 2, 3, 3, 2, 3, 4, 3, 5, 3, 6. Binary invert, truncate, two zero invert. Okay, execute this. Okay, so these are the different thresholding techniques. Okay, just give it the titles also, then you'll able to get the difference. Plot dot title, so it is original image. Plot dot axis of. Okay, just it is binary, it is binary invert, it is truncated technique, so it is last one 20, so it is 20 invert. Okay, so this is how different thresholding techniques can be implemented. So these different techniques will work in a different manner. So both all will work on with respect to the threshold value only. It is going to change the pixel value in the image with respect to the threshold value, but how it will going to change, so that is that makes the difference among these different techniques. Okay, so first one is the threshold binary. So this threshold binary will convert the pixel value. If it is found to be less than the threshold value, then it will convert it to 0. If it is greater than the threshold value, it will convert it to maximum value. Threshold binary invert does the same thing in the opposite way. That means if the pixel is found to be value which is less than the threshold value, it makes it as maximum value. If the pixel value is less than the threshold value, is make it as a maximum value. If it is greater than the threshold value, it makes it as a pixel value at 0. Okay, truncated. So it will how does it work is, if the pixel value is found to be greater than the threshold value, it will truncate those pixel value to the threshold value. That means if the pixel value is 174, I have given the threshold value as 100, then the pixel value which contains the value 174 will be converted to 100 only, and the pixel value which is found to be less than the threshold value, it keeps as it is. Okay, so that's why if the pixel value is greater than the threshold value, it will truncate those threshold it will truncate those pixel values to the threshold value. Okay, so next is threshold 20. So here pixel intensity is set to 0 for all the pixel intensity less than the threshold value. Okay, in threshold 20 invert, it works as opposite to the 20 method. If the pixel intensity is greater than the threshold value, it sets it to 0. Okay, so that's how these different techniques will be implemented. So this is about the simple thresholding technique. Okay, you can just have a copy of it. So I'll send you the file to you, so then you can execute it. Just note down the difference here. How can these different techniques can be implemented, and what makes the difference in changing the pixel value in different techniques. Okay. Fine. So next we shall move on to the next type, which is adaptive thresholding. Okay, so adaptive thresholding is also another type of thresholding. Here what happens is, it's not like the simple thresholding. In simple thresholding, you just change the pixel value based on the threshold value. Like it will going to we being a user going to specify the threshold value, that the threshold value should be like 100, 120, 130, like this. But in case of adaptive thresholding, the threshold value is not constant for all the pixels. Okay, so a constant threshold value will not be used in adaptive thresholding. Instead of that, in adaptive thresholding, the threshold value is calculated for a smaller portion in the image. Okay, so it's not constant. Like ನೀವೀಗ simple thresholding ಅಲ್ಲಿ 100 ಅಂತ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ರಿ ಅಂದರೆ, ಒಂದು ಇಮೇಜಲ್ಲಿರೋ ಪ್ರತಿ ಪಿಕ್ಸೆಲ್ ವ್ಯಾಲ್ಯೂ ಜೊತೆ ಆ 100 ಅನ್ನೋ ವ್ಯಾಲ್ಯೂ ಕಂಪೇರ್ ಆಗುತ್ತೆ. ಪ್ರತಿ ಪಿಕ್ಸೆಲ್ ವ್ಯಾಲ್ಯೂನು 100ಗಿಂತ ಜಾಸ್ತಿ ಇದನೋ ಕಮ್ಮಿ ಇದ್ದರೆ ಏನು ಮಾಡಬೇಕು, ಜಾಸ್ತಿ ಇದ್ದರೆ ಏನು ಮಾಡಬೇಕು ಅನ್ನೋದನ್ನು ಚೆಕ್ ಮಾಡಿ ಆ ಥರ ಕನ್ವರ್ಟ್ ಮಾಡ್ತೀವಿ. ಬಟ್ ಇನ್ ಕೇಸ್ ಆಫ್ ಅಡಾಪ್ಟಿವ್ ಥ್ರೆಶೋಲ್ಡಿಂಗ್, ಇಟ್ಸ್ ನಾಟ್ ಸೇಮ್ 100 ಫಾರ್ ಆಲ್ ದ ಪಿಕ್ಸೆಲ್ಸ್. Okay, so instead of that, it will going to calculate for a smaller portion in the image. and that makes the difference different threshold values for different regions in the image. Okay, with respect to the changing in the intensity of the pixels in the image. Okay, so it is going to consider smaller portion, and what are all the pixels which are present within that portion. We are going to consider those pixels and do some calculation, which means it can be like calculating the average of all those pixels in that small portion, and set that value as a threshold value. Okay, so if I consider this as an image, and I'll consider this portion, first four columns, 4 rows of values in there. So I'll take that portion and I'll calculate the average of all the pixels which lies within that region, and I'll make that value as a threshold value for this area. Okay, and I'll come to the next portion, and I'll consider that portion pixels, and I'll calculate the average of those pixels, and I'll make that average as a threshold value, and I'll convert all the pixels within that region with respect to the threshold value which is calculated for that portion. Okay, so likewise I'll do the same operation for all the portion in the image. Okay, so that's how adaptive thresholding is going to work. Okay, so there are two different techniques in adaptive thresholding. First we should see what is adaptive thresholding. In adaptive thresholding, threshold, it is same like simple only, but the difference is threshold value is not constant. It will be calculated for smaller regions, a small portion of the image. Okay, so based on this calculation type, there are two different types. One is if the threshold value is calculated using a average, finding out the average technique. So it is called thresh underscore mean underscore C. Okay, it can be called as CV2 dot adaptive thresh underscore mean underscore C. This is one technique, and another one technique is thresh underscore adaptive underscore Gaussian. It's not thresh adaptive threshold underscore Gaussian underscore C. So these are the two different techniques which can be available in the adaptive thresholding. Fine. So let us implement this. Okay, the smaller portion ನಾವೇನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ ಅದರೊಳಗೆ ಬರೋ ಎಲ್ಲ ಪಿಕ್ಸೆಲ್ಸ್ದು ಕನ್ಸಿಡರ್ ಮಾಡಿ ಅದನ್ನು ಒಂದು ಸಮ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿ ಅಲ್ಲಿ ಏನು ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ ಅದನ್ನು ನಾವು ಥ್ರೆಶೋಲ್ಡ್ ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ ಇನ್ ಚೇಂಜಿಂಗ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಆಫ್ ದ ಪಿಕ್ಸೆಲ್ ಇನ್ ದ ಒರಿಜಿನಲ್ ಇಮೇಜ್. Okay, so based on that calculation way, so there are two different types. One is adaptive thresholding mean and adaptive thresholding Gaussian. In the first technique, we are going to calculate the average of all the pixels which is present in the smaller portion which we have considered. In the second technique, adaptive thresholding Gaussian, we are going to calculate the method. We are going to calculate the Gaussian weight for all the pixels within that portion. Okay. So let us implement that the same way as we do in the binary thresholding, but the difference is the method used for implement the adaptive thresholding is adaptive threshold. Instead of threshold, you are going to use it like adaptive threshold. Original mean adapt. Okay, it is Gaussian. Same image, we're going to convert it to First method, it is adaptive threshold, not just a threshold, it is adaptive threshold. Okay, so adaptive threshold, T, it is 3. Adaptive threshold is the method which will be used for implementing the adaptive thresholding technique. Here we need to specify the first parameter as the image source, second will be the maximum value, and third is the thresholding technique. CV2 dot adaptive threshold mean underscore C. Okay, so next we need to specify the technique. Okay, so ಇದು ನಾವು ಇಲ್ಲಿ ಡಿಫ್ರೆನ್ಸ್ ಏನಂದರೆ ಬರೀ ಥ್ರೆಶೋಲ್ಡ್ ವ್ಯಾಲ್ಯೂನ ಹೇಗೆ ಕೊಡ್ತೀವಿ ಅನ್ನೋದು, ಹೇಗೆ ಕನ್ಸಿಡರ್ ಮಾಡುತ್ತೆ ಅನ್ನೋದು. ಓಕೆ, ಸೊ ಸಿಂಪಲ್ ಥ್ರೆಶೋಲ್ಡಿಂಗಲ್ಲಿ ಡೈರೆಕ್ಟಾಗಿ ಕೊಡ್ತೀವಿ ಥ್ರೆಶೋಲ್ಡ್ ವ್ಯಾಲ್ಯೂನ. ಅಡಾಪ್ಟಿವ್ ಥ್ರೆಶೋಲ್ಡಿಂಗಲ್ಲಿ ವಿ ಗೋಯಿಂಗ್ ಟು ಗಿವ್ ಇಟ್ ಬೈ ಯೂಸಿಂಗ್ ಅ ಟೆಕ್ನಿಕ್, ಸಮ್ ಟೆಕ್ನಿಕ್. ಓಕೆ, ಸೊ ಅದಾದಮೇಲೆ ಆಗೋ ಥ್ರೆಶೋಲ್ಡ್ ವ್ಯಾಲ್ಯೂ ಫಿಕ್ಸ್ ಆದಮೇಲೆ ಯೂಸ್ ಆಗೋದು ಸೇಮ್ ಮೆಥಡ್ಸ್, ಸೇಮ್ 5 ಮೆಥಡ್ಸ್: ಬೈನರಿ, ಇನ್ವರ್ಟ್, ಟ್ರಂಕೇಟೆಡ್, 2020 ಇನ್ವರ್ಟ್. ಸೊ ಥ್ರೆಶೋಲ್ಡ್ ವ್ಯಾಲ್ಯೂ ಫಿಕ್ಸ್ ಆದಮೇಲೆ ಯಾವ ಥರ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು ಅನ್ನೋದನ್ನು ವಿ ಹ್ಯಾವ್ ಟು ಸ್ಪೆಸಿಫೈ. ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್, so 2 more concepts we need to specify. That's the block size. Block size means the last parameter. Block size is, so it's the size of the pixel of the neighborhood that is used to calculate the threshold value. Okay, so usually it's 99, and the constant value we need to pass, and this will be the value that is subtracted from the mean or the weight sum from the neighborhood pixels. These are the mandatory parameters we should pass. So next, if we implemented this, so just here just give Gaussian C, Gaussian C, just mean. It's a Gaussian method. Okay, so we executed this. Okay, adaptive threshold, uppercase T. Adaptive threshold. Adaptive threshold. Just a sec. Adaptive threshold, image maximum value, adaptive threshold mean underscore C. Okay, so it will return only one value, not a return value will be present for this. Okay, so this is original image, this is mean thresholding, adaptive mean, this is adaptive Gaussian. Okay, so Gaussian weight will be calculated. It uses some equation to calculate the threshold value. Okay, so these are all the different adaptive thresholding techniques. Okay, so observe the difference.
Yes.
Yes. Okay, so make out the difference. Just note down the methods, these two methods. Okay, so next we should move on to the next technique, which is called Otsu thresholding. So Otsu thresholding is another kind of thresholding and the type of thresholding. In this, the difference is the threshold value is calculated by plotting a histogram of an image and by considering the two peak values in that histogram and calculate the average of it, and that will be the threshold value for this kind of threshold technique. Okay, so also thresholding, it will going to calculate the threshold value by considering the histogram of the image. Okay, so in also thresholding, how the threshold value is calculated. So threshold value is not chosen or determined automatically. It will going to calculate by using the histogram. Okay, so the method here, threshold is calculated using histogram. In this, top two peak values are considered, and take the average of these two pixels, these two values, average of two peaks, that will be the threshold. Okay, so this is how threshold value will be calculated in the also thresholding. Rest all the methods remains same. Okay, so the method here is used threshold only, not also threshold or adaptive threshold. It's threshold again. So CV2 dot threshold, and here we need to pass the parameter. One is the image source and the threshold value, maximum value, thresholding technique. Okay, here we need to pass the threshold value, but the threshold value will again change with the thresholding technique which we are going to specify as a thresholding technique. Okay, just copy this. Okay, thresholding technique, but here the method we need to pass for this method is the image source, that is I1 dot and the next parameter we need to pass is the threshold value. Next value we need to pass is the maximum value, and the technique, that is CV2 dot thresh binary. Along with this we need to pass one more parameter called as CV2 dot thresh also. Okay, so this is the format of the method which you need to use to implement threshold, also thresholding. Okay, just use binary itself, original I1 this is binary, it is the also, so this is original. Okay, subplot. this is the original image and this is the subplot. Fine. So this is how different thresholding techniques can be implemented to change the pixel value with respect to the threshold value. So these kind of things you are going to observe in the medical field, in the x-rays, in the MRIs. So ಈ ತರ images ನ ನೋಡಿರ್ತೀರಲ್ವಾ. So those are all this kind of operation can be implemented. Fine. So this is how different thresholding techniques can be implemented. We have seen with the 3 different techniques or 3 different types and 5 different techniques. These are the types and these are the techniques. Simple thresholding, adaptive thresholding and also thresholding. Techniques are threshold binary invert, threshold truncate, threshold 2-0, threshold 2-0 invert. Okay, so this is how we can implement the thresholding techniques. Fine. So what all the concept we have discussed today, we have seen, just brush up the yesterday's class, and we have seen how can we perform the basic operations with the images, like accessing the pixel values and modify them. Modify them is what the thresholding techniques we are going to do. Okay, so, and access image properties by using a shape attribute, setting the region of image by using the rows values and by using the dimension of the image. Okay, so this is how we can perform the slicings and we can extract the region of interest. Next, we have changed the color space of an image in different ways. And we have extracted the different channels which are present in a colored image and changed the color spaces. We have plotted the histograms and analyzed the image. And next we have performed the thresholding on the image. Okay, so these are all the concepts we have discussed in today's class. Okay, so if anybody have any doubts in today's class, they can ask me now.